Students, let us solve a problem related to bond angles. What is the correct order of decreasing bond angle? Option A, NH4 plus greater than NH3 greater than NH2 minus. Option B, NH3 greater than NH2 minus greater than NH4 plus. Option C, NH2 minus greater than NH3 greater than NH4 plus. Option D, NH3 greater than NH4 plus greater than NH2 minus. Now, we need to predict the correct order of hybridization. To predict the correct order of hybridization, first we should find the hybridization. Based on the hybridization, we can decide the bond angles to some extent. If the hybridizations are same, then should go for the electronegativity of the central atom. If the electronegativity of the, we should go for the number of lone pairs of electrons. As the number of lone pair of electron increases, the bond angle decreases. If the number of lone pairs are also same, then we should go for the electronegativity of the central atom. Let us try to solve the problem. First we will calculate the hybridization. The molecules that are given are, one is NH4 plus, other one is NH3, the next one is NH2 minus. Hybridization of NH4 plus, nitrogen in NH4 plus. H is equal to half of valence electrons of nitrogen. Nitrogen atomic number is 7, hence it contains 5 valence electrons, plus 4. Why? Because hydrogen is monovalent. Minus 1, so plus charge you should subtract it. 5 plus 4 minus 1 is 8, 8 by 2 is 4. 4 indicates the hybridization is sp3. Now, in NH4 plus, nitrogen contains 4 hybrid orbitals. Nitrogen is linked to 4 hydrogen. That means all the 4 are bond pair, it doesn't contain any lone pair. If all the 4 are bond pair, then the shape is perfect tetrahedral and the bond angle will be 109 degree 28 minutes. Let us find the hybridization of NH3 and let us predict the bond angle. Hybridization of nitrogen in NH3 is half of 5 plus 3, because hydrogen monovalent 3, it does not carry any charge. So 5 plus 3 8, 8 by 2 is 4. Again the hybridization is sp3. Now, since the hybridizations are same, you should consider the number of lone pair also. NH3, in NH3 the hybridization is sp3, indicates nitrogen contains 4 orbitals. Nitrogen is linked to 3 hydrogen, that means out of 4, 3 are bond pair and 1 is lone pair. That means since the hybridization is sp3, the arrangement should be tetrahedral. Since it contains 1 lone pair, 1 position will be occupied by lone pair, 3 position by bond pair. Since the hybridization is sp3, the bond angle should be around 109 degree 28 minutes. Since it contains 1 lone pair, the bond angle will be less than 109 degree 28 minutes, because the presence of lone pair decreases the bond angle. NH2 minus, H is equal to half of nitrogen 5, hydrogen 2, plus 2 7, minus we should add 1, 5 plus 2 7, 7 plus 1 is 8, 8 by 2 is 4, 4 indicates the hybridization is sp3. sp3 indicates nitrogen contains 4 orbitals, but nitrogen is linked to 2 hydrogen, that means there are 2 bond pair and 2 lone pair. Now, since the hybridization is sp3, the arrangement should be tetrahedral, indicating the bond angle should be nearly 109 degree 28 minutes, but lone pair decides it. Now, there are 2 lone pairs, that means out of 4 positions, 2 positions are occupied by lone pair. So the bond, since there are lone pair present, the bond angle will be less than 109 degree 28 minutes. Now, NH3 also contains lone pair, NH2 minus also contains lone pair, but NH2 minus contains 2 lone pair. The bond angle will be still less than 109 degree 28 minutes. So if you want to predict the correct decreasing order, that is the molecule with higher bond order is NH4 plus, next comes NH3, next comes NH2 minus. Hence the correct answer is option A, NH4 plus greater than NH3 greater than NH2 minus.